Hello, guys. Oh, it's another great Saturday. Really, really happy to be here. Wow, I feel like we're achieving so much. I feel like we can now do amazing stuff in deep learning. There's still a lot of things we still need to learn. That's for sure, right? A lot of definitions and a lot of coding syntax that we need to learn, but I'm pretty sure that so far we've made amazing progress. So let me just put on the comments so I see who is online. I know that this might look a little difficult at first. Like I mentioned last week, it is repetition that makes it easier. The more you see it and the more you try to do it, the better you become at it. The first time you see it, it's intimidating, right? When you see the code, you're like, how do I even start? Where do I start from? What do I do? What does this mean? Yeah, all those questions. I went through it. Every other person who codes goes through it too, right? So um, you're not alone. You can always ask questions. You can reach out to Kuderina, hello@kuderina.org. Any questions you have at all, we're here for you, right? I'm doing more talking before I start out because I know that's where most of the work is. It's in the mind, right? It's your mind game. Um, any challenge you have, watch the program over and over. If you have to stop at any particular point, maybe if a 5 minute interval, you could take time. If you're having issues, if it's too um, intellectually tasking for you, that means you're having headache or something like that. Yeah, sometimes you could have headaches. You could just take a break, take a 5 minutes break, 10 minutes break, do something else. Drink water, drink a lot of water, and then come back to it. When you come back to it, it becomes easier, right? Because your mind has stretched to understand and accommodate it, right? Okay, so let's jump into the code one more time and walk through it. Um, it should be easier now. It should be way, way easier now. And I'm hoping I want somebody to have done something with it. So I want you to have gotten pictures of your family members. Yeah, you can take pictures with your phone. Take pictures with your phone. Now you know how. If you don't know how to take pictures, go back to week one and then check for the kind of pictures you need to take. Yeah, you need to take frontal pictures, you need to take side pictures, you need to take um skewed pictures, whatever it is, for different angles. Remember, AI is data, right? It is prediction from data. It is learning from data and then predicting on other data you've not seen, right? So you want to give it as much data as possible. You want to give it as um, um, a very wide, diverse kind of data, different kinds of data of the same thing. So that means the same face, in our case, the same face, but different ways or different angles to see the face. So maybe a camera from this side, a camera from here, a camera from here, a camera from here, a camera from here, another kind of background, a skewed head, a flipped head, whatever, different kinds of images, so that depending on how your image comes in, it knows, oh, I've seen this kind of image before, so I know that it has to be this person, or I know it has to be this person. It's not confused, right? Or its level of confusion is reduced, right? So that's why you need to get as much data as possible. If you can get say if you can get at least mm, to have a pretty decent model, if you can get say 30, yeah, 30 could be fine. I wanted to say 50 or 60, but um, getting 60 images of one person, like your dad will just get tired of waiting for you to take pictures, or your brother or your mother. But then you could explain to them that it's for your project, all right? So I'm looking forward to that. I want to see what you guys have done with it. I want to see what you guys have done with it, right? It's easy. I know it's tasking, but it is easy. After a few trials, it becomes easy. All right, so let's jump into the code. I'll just share my screen in a few seconds. Okay, fantastic. All right, so let me just jump to my code. Okay, so I'll walk through the code again. Pretty much the same thing. No, I've not made any changes. So we have first line of code, or this first cell is basically to connect your drive to your collab. Um, Again, if you don't know how to get access to collab, all you have to do is have a Gmail account. Once you have that Gmail account, you probably would see it here, right? You would see your account. In this case, mine is here. And so from there, I could just click on or type in Google Colab, right? That's all. And then you just go into welcome.colab. That's what you need to do the pretty amazing stuff that we're doing here. Again, our advice, some of you try to use your local system. You're trying to use PyCharm. Please don't use PyCharm. Please don't use your local system. Please don't use your VS Code. Use Colab, especially for deep learning. Your system might not have what it takes, what you need. You'd run into a lot of errors if you use your system, just your system, or if you try to use Jupyter Notebook. No, use Colab, right? So, and all you need to do is just type in Google Colab into your browser, and then that's all you need to connect. Click on Welcome to Colab and then create a new notebook. You would see it somewhere around here, right? Or you could go through File around here. You know what? Let's just go into it. Yeah. So you either see it here, click on New Notebook. If you don't see this, that's fine. Just come out and click on File here and click on New Notebook. They're the same thing, right? And then you get a new notebook. And then yes, you might need to copy out this code line by line, which is absolutely fine because it does two things for you. It helps you learn to type better. It helps you learn to code better. Typing out code makes you type better. It's like writing. The more you write, the better you become at writing. The easier it is for you to write. Right. So that's what's happening there. So yeah, this code, I'll just walk you through what the code does so you know what it does. You don't necessarily need to know very deep things inside. Again, I'm particular about you just doing a very simple, use the code you have, right? And to do a facial recognition software or program. Then after you've gone through that process, you can now start breaking it down little by little, right? Okay. So, this first code is supposed to connect your Google Drive to the Colab, right? So once I run it, it connects. It's connecting here. You can see it. Initializing. Mounting my Google Drive. You can see here. Good. So it's mounted. That means it has connected my Google Drive to this Colab here. Okay, so and then we talked about importing dependencies. This is the code you need to copy. Yeah, and I should mention you should learn to type fast, right? You should learn to type fast. For example, right? I did that in pretty much over a second. So if you don't know how to type fast, you shouldn't be looking at your screen to type or looking at your typing board or keyboard to type, right? You should be able to type without looking at your keyboard. Practice it. Get a hold of Maui's beacon and start practicing it. It will help tremendously to help your coding skills tremendously, right? I type without having to look at my keyboard because I know where everything is in my mind. And then my hand just works automatically. It makes your typing faster, and your coding better, right? So yeah, and I say this because you might not have access to this collab, but if you want access to the collab, all you have to do again is just send your email to hello@coderina.org, hello@coderina.org, and then you get access to this collab, right? But yeah, I encourage you to type it out. I encourage you to type it out. Okay, so after we imported our dependencies are basically what your um, code would need to run with. So, for example, there are different codes for different things, and then you can use dependencies to get access to those things. So, for example, if you want to get access to making or handling images, because you're going to be passing in your images into the Colab, there's a dependency or a library that will help you take your image, pre-process your image, and then pass it into the AI per se, or pass it into the neural network. I explained what neural network means in the previous class. I would encourage you to go back and look through the video, right? I encourage you to go through the video. That would help you understand what neural networks are. Um, but neural networks are, you could think of them as AI, right? They are the um, they are what learns your image. They are what learns the pattern in your image. They are what learns to call your mom's face your mom, and learns to call your dad's face your dad, or learns to call your face your face. They are what learns to call a cat, or a mouse, or um, a dog, right? So it's the AI that we actually pretty much talk about. That's what neural networks are. The AI in the tech in being technical is saying neural networks. If you're not being technical, for general people, you say it's AI, right? So and then there's a way they take in image. They don't just take in any kind of image. The image has to be pre-processed. So that image you see has to be converted to numbers, has to be turned to numbers, array of numbers. We talked about arrays in Python class, array of numbers, right? So they have to turn that image into numbers and then push those numbers into the neural network. The neural network processes it and understands the numbers. Yeah, it understands numbers, and then it will print out numbers to you. Then you, being an AI professional or an AI student, you turn that numbers to what people can understand, right? People who don't understand AI, right? So all these things I mentioned is the flow of tensors. So those numbers, those array of numbers, they are tensors, right? They're actually tensors. So what do you do? That's why we have TensorFlow. TensorFlow is it's a library used to do all these things I've mentioned. Library used to build your neural network. Library used to convert your image to numbers, to tensors. Library used to pre-process your image. Library used to learn your image or the numbers or the tensors of your image, and library used to give out predictions and probably outputs and say, oh, this is a dog, this is a cat, this is Daniel, this is Blessing, this is Mercy, this is whoever you train it to understand, right? So everywhere you see TensorFlow here, they are either playing the role of converting your image to numbers, or they're playing the role of creating neural networks for training, or they're playing the role of prediction, right? So that's why we need all these libraries, all these TensorFlow libraries here. And of course, I explained what NumPy means. NumPy basically means numbers or number arithmetics with Python, right? It's a library that helps you do number arithmetics, be it addition, multiplication, exponentiation, or be it advanced calculus and all those other pretty advanced things. We can't begin to write all those codes. If we start writing them, it will take all the time. That's why we need they've been written somewhere, so we're just going to call them and use them in our code here. All right, so that's that about. Then, of course, yes, scikit-learn is also one machine learning library that helps you, that gives you access to different machine ML libraries that you can use for your training, but that's beyond the scope of this course. All right. OS basically gives you access to um, use, maybe you want to get files from your system. Basically means operating system. That's what OS means, operating system. So we want to get access to the files in your system, or you want to move a file from one part in your system to another part in your system. Yeah, and random is to maybe generate random numbers or scatter a list or randomize things. That's what random is for. All right. Then piplot is if you want to visualize, it can give you graphs, diagrams. If you want to see the image that you pass into the system, piplot can help you see the image. That's why it's plot. Plots is a graph, right, that plots images for you. And then we're using matplotlib inline because on Colab, that's the only way you can actually get to view your graphs that are plotted. So that's why we have to put by a matplotlib inline. Okay, so we're just going to run that to get access to all those libraries. All right. Okay, so now in our first class we worked on getting the images. So I presume that you've gotten the images you need, and we worked on how many images did we work on? I think we worked on two. We worked on Chris Brown, and then we worked on Jennifer Aniston, right? And then we stored them into this recognizer folder in our drive. Remember, if you don't know what this means, please go back and watch the video in our drive. This is basically all you need to do. This is basically the most important thing you need to do. The rest, you just need to run the code and it will work for you, right? What you're just working on is getting the data. Once you get the data, you're good to go. Right? So we're saying this is where we store. And then, yes, I explained training and validation. So when you train, right, you would have to test to see how well your model learned. So that's why you need validation data. So validation data basically means, okay, so for example, you've given it 30 images of your mom from different angles. So you might want to give it an image of your mom in, maybe all these images you took was your mom in, which country should I use? Say America, right? Um, yeah, say America, or which, yeah, let's use America. And you now want to test to see how well you can recognize your mom in any place at all. So maybe your mom will take a picture in China with a different background, with a different kind of background, right? So the idea is it is supposed to um, be able to still recognize your mom in a different background, right? So that's why you need validation data. So validation data is data it hasn't seen before. It trained with your training data, and then to test itself how good it is with your validation data. That's what's happening there. So that's why you need two sets of data, right? So if you have 30 images of one person, or 40 images or 50 images, you want to split that into two, but not 50-50. You want to split it into maybe 80-20. So you have more. If you have 50 images, you want to split it into 40-10. Or if you have um, in our case, we have about 25 images, and then we split it into 20 images for training. So it has more data to train on. And then it has about five images to test on, right? So that's what training and validation directory means. So I'm saying this is the directory where you are going to find the training data. And then this is the directory where you're going to find the validation data. Let's quickly inspect this directory. So this is the directory, right, for training. So in training, we have Chris and Jennifer Aniston. I presume we have about 20 images. Yeah, we have about 20 images, right? And then for Aniston, pretty much the same, about 20 images. Yeah. But for tests, we have the same set of people, but then we don't have a lot. We just have about 6 images for Chris and about 5 images for Jennifer Aniston. Again, it doesn't have to be a lot, just a smaller chunk. The rule is 80-20, 80-20. So 80 for, it could be 80-20, it could be 75-25, it could be 70-30. It depends on you, but it has to be a smaller chunk for your validation and test. All right, so that's how we define where it is. So we just need to run this cell. Okay, so then we come down to data augmentation. So we talked about this. We said sometimes your data might not be as varied enough. And even if they are, you want them to be as more varied than they are, right? When I say varied, I mean um, different variations of the same image, different kinds of the same image. So is it going to skew the image? Is it going to flip the image? Is it going to turn the image to the right or to the left? Is it going to different things? What will it do? So this API, image data generator in TensorFlow, helps us do all those things to our image. It helps us rotate the image. It helps us share the image. That means skew the image. It helps us zoom the image, maybe come into the image like this, or zoom out like this. It helps us flip the image. So maybe flip it up or flip it down, or rotate the image like the first parameter. It helps us fill mode. So fill mode basically means if you've um, if you've skewed an image, you've shifted the image like this, there will be an empty space here that wasn't there before. How does it fill it? They basically mean nearest means fill it with the same set of um, maybe white background that is here. Does that make sense? So yeah, that's basically fill it with the pixel values that are closest to the empty place or to the empty space that was created. That's basically what it means. Training directory, yeah. We're saying now we've created a class. Remember, we create class with capital letters. We've created this class, the image data generator class, or the class has already been created for us. We just called it, and then we're putting it into this variable. So we say with everything that we've told you to do here when you were created, that's what this means. Do it inside, take the images inside the training directory, reduce the size of those images to 224 by 224 because that's what the neural network can take. The neural network takes in 224 by 224. Very important. If this is not 224 by 224, you have errors. MobileNet takes in 224 by 224. Okay, then take a batch size of 5. That means take 5 each. We have about 20 images or 25 images in our training directory. So it's going to take them 5. So it's going to take 5, learn from 5, go back, take another 5, learn from the other 5, go back, take another 5, take the next 5. You keep doing that until it finishes learning. It's going to be taking them in 5. So if I put 10, it's going to be taking them in 10. So that means it will run only, if you have 25 images, if you're taking them in batches of 5, it will run 5 times. If you're taking them in batches of 10, to run 3 times. So that's 10, 20, 25. And then we're saying categorical. If it were just to okay, let's just leave this as categorical. Sometimes you might see it as binary, right? If you're doing just 2 classifications. In this case, we're doing 2 classifications, but I want you to use categorical because you might be doing more than 2 classifications. So maybe your mom, your dad, yourself, your auntie, your uncle, as fast as more than 2, use categorical. So I'm just using categorical because I expect that you guys will be doing more than 2 classifications. All right, so and everything here is, so we said apply this training data gen, take our images from this directory, do all this to it, and then pass it into the training into this image data generator and do everything we mentioned to it. Once you are done, put it inside the train generator. Then we'll train with this. I hope that makes sense. Let me run through again. We've created an image data generator. We said, now take our images from this directory, reduce the size or make it into this target size, take them in fives, and then know that we're doing a categorical classification of categorical classification. And then once you apply all this, apply this train data gen here, apply it to the images here, and then pass that into, so this is our preparation, right? Pass that into those prepared images into train generator. So this would turn all the images in our training directory into numbers. You can see the preprocessing here. It's going to turn it into those numbers that we spoke about, right? And it's still going to do those things we mentioned here. Okay. So we're doing the same thing, almost the same thing to our validation data generator. We don't need to skew and turn and change our validation and rotate our validation data because we want to test with it. In real life, if you're testing something, you don't have to start changing or skewing or doing, you just take the image and pass it to the AI and it tells you. So it's in the training that you have to do all those variations, but in validation or testing, you don't do all those variations. You just, what do you think about? You ask the AI, what do you think about this? What is it exactly? Right? Okay. So once we run this, you would see that we have 40 images belonging to two classes for the training directory. That's 2020 each for Chris and Jennifer Aniston. And then we have 11 images in the test directory or validation directory belonging to Chris. That's, I think, 6 for Chris, 5 for Jennifer Aniston. Okay. So we're going to fine tune our mobile net. Now, we are not building a mobile net we're not building a neural network from scratch, right? I explained to you why we need to use a pre-trained neural network. A pre-trained neural network gives us several things, several capabilities. If we're going to train our own from scratch, first of all, we need a lot of money. We need a lot of compute. We need a very large, very powerful computer or computers. We need GPUs, those resources. So, and those resources might be a lot to have or come across, right, for you in your house or in your office or wherever you are. So, what we can do is we can take advantage of pre-trained neural networks that have already been trained by Google, Microsoft, um, um, IBM, Tesla. Those companies have a lot of money, they have a lot of compute, they have a lot of resources that they have, and they have a lot of scientists, engineers that have spent their time teaching these neural networks how to understand several things. Sometimes with as much as 1 million images. In fact, most times more than 1 million images, right, of different things. And then they would label them. Here we're working with 20 images. Imagine working with 1 million images, right? At least, or 10 million images, right? And they would have to annotate all of them one by one, right? So we don't have to do that from scratch. We can just take what they've learned and then fine tune a little to our own particular use case. So in this case, we want it to be able to recognize maybe my face or your family's face, your father's face or mother's face, right? But the neural network already understands, it knows how to recognize human beings. Does that make sense? All you're now teaching it to do is to understand um, um, a particular human being, right? One particular human being. So that's what is happening here. That's why we need to use something like mobile net. Mobile net is lightweight. It's something you can deploy to your app. That means you could make an app that recognizes people. All they need to do, once you just take a picture of the person to tell you who the person is. Um, I probably will show a demo of that in next week's class, by God's grace. Um, yeah. So mobile net is a fantastic. That's why it's called mobile, right? Mobile is for probably your phone or for smaller devices, right? Um, so yeah, how do you now get access to mobile? You use tf.keras.applications.mobilenet.mobilenet, and then the input shape, how it takes in image, it takes in, like I explained, 224 by 224. I told you this is three because you're using colored images. If you're using black and white images, this should be one. And then we're saying we're taking everything, all the layers. We talked about layers. You can watch the previous videos. We're taking everything up until the last six layers. That means we're not taking the last six bottom layers. We're taking everything from the top down to the last six layers. And I explained what these layers do. You can also visit the previous videos to understand. I spent a whole lot of time explaining them. So, um, yeah, and then so once we've taken that, we called mobile. We're taking only all the layers up until the last six layers of mobile. We're putting that into X, and then we're saying we're adding our own output to it. That means we're adding our classification output to it. So we're saying we have just two classifications. If you have three classifications, then maybe your mom, your dad, and yourself, this should be three. If you don't do that, you're going to run into an error. Um, you probably will see um, oh, I can't place my hand on the exact error you're going to see, but you're going to get an error. So, um, this is supposed to be equal to the number of images or number of folders you have here. In this case, we have just Chris and Aniston. Chris and Aniston, right? That's why we have two here. If I had three people here, this would be three, right? And then you use a softmax activation function. Then you connect your mobile net to it. That's what this X means here. And then you make this a dense layer. That's what it means. Explaining what it means or what dense means is beyond the scope of this course. We'll get to explore it sooner, maybe later. Um, and then we're now going to put everything together, right? Um, let's see. Okay, so now everything is in the output variable, right? You've created your output variable here. How you want the model to output information. That's what this is here. And then you pass it into these outputs. Again, you must be careful about syntax. If you make any error with the syntax, you would have an issue. So that what that means is if you're supposed to write output with an S and you write output without an S, you will get an error, right? So you have to type in exactly what you see here, All right. So if you run this, it's going to get us the mobile net, and then you connect that to your model. And then yes, this particular line basically means you're turning um, everything, every layer that you've created up until the last six layers again. This is another set of six layers to be false. That means they can't be trained. I explained this again too in a previous video. They cannot be trained, right? So Okay. So everything up until the last six layers is not trainable. That's why we say trainable is equal to false. Is not trainable. So we're only training the last six layers. That's what it means. If everything up until the last six layers is not trainable, let me do this so it makes better sense. Um, Layer one. Okay, so let's say we have layer one, two, three, four, five, six, seven, sorry, seven, eight, nine, 10, 11, 2, 12. Okay. So everything up on the last six layers, that means everything from here upward is not trainable. The last six layers are trainable. That's what this means. Right? Everything up until the last six layers. If this was even layer 13, there was a layer 13, that means this one, two, three, one, two, three. Yes. Everything upward will be on not trainable. The last six layers will be trainable. So that's what this code means. This line of code means. All right. So let me just wipe that off. I'm leaving this here because of what we discussed about. Okay. So let's check what our model looks like. Okay. So this is what our model looks like. We're not training all these ones, all these parameters. We're training these parameters, right? Okay, so um, okay, so after, sorry, I was just looking through the code. Okay, so after giving it the non-trainable parameters and trainable parameters, you want to now compile the model, right? And you compile the model using optimizers and loss functions. So the optimizer we're using here is Adam. Adam happens to be the best optimizer at the moment. There is root mean square prop, that's RMS prop. There is adaptive gradient descent. There's gradient descent. There's stochastic gradient descent. There's mini batch gradient descent. But in this case, we're using Adam optimizer, right? And they were giving a learning rate of 0.001, and then we're saying this is categorical cross entropy. Assuming we're doing just two classifications, this would be binary cross entropy or sparse binary cross entropy. But in this case, we're doing categorical cross entropy, so this is fine. Metrics, we're using accuracy. That means we want it to um, classify correctly. We're telling the model to learn to classify correctly. That's what this is. Okay. Okay, so and on this note, we'll just, with all this we've done, we've compiled the model. So now let's now fit or train the model using our training images got from train generator up here. Train generator here. Right? Epochs, how many times should you train for? verbose. I told you verbose because we want to see what the accuracy is like growing, changing. Both the accuracy on the test and accuracy on the validation, which is all your val accuracy and normal accuracy, and then want to see what the loss is on on the training and loss validation loss on the test, right? And then validation data is equal to validation generator, right? Um, Then callbacks, tf.keras.callbacks, early stopping. I explained that this means that we're going to watch out if instead of training for actually training 20 times, that's going through the images 20 times. That means to go through from, um, we have 40 images, to go through 40 images once, learn, come back again, learn again, come back again, learn again, come back again 20 times. We want it to stop when the validation loss has is no longer changing. That means we waited 2 epochs and it didn't change. It didn't go down. It's supposed to reduce. It didn't reduce. Right. So once it gets to that point, stop the training. So that's what this callback means. Well, apparently he didn't learn so well. Our accuracy is fantastic, yeah, but our val accuracy is not doing very well, right? It's not doing very well because this has to be, say, roughly almost equal to each other. So we have 92 here, we have 45. That's almost half. That's not good. So what do we do? Let's try and find the error. Let's run it for 20 epochs and see, 20 more epochs and see what it's going to be like. Okay, it's doing pretty well on. Okay, so we can see that our val accuracy is increasing or has increased. Excuse me. Okay, is increasing. So you can see that it's getting to 20 because we stopped the callbacks. Hmm, interesting. So what that means is we stopped too early. It actually could actually get to 100%. That means perform almost perfectly well. So we stopped too early. So what we can do is let's make this a, let's check on up until 4, and then let's start the process all over again. Okay, let's see. So we're starting afresh. Okay, starting pretty good. Doing pretty good on val accuracy. Guys, your val accuracy is very important. Very important. You don't necessarily have to look at just your accuracy on training, because your val accuracy will tell you how well it's going to perform on real life data. That means data it hasn't trained on. You can see that the val loss is steadily decreasing. We're doing about a 90 here now. A 100. This is pretty good. Okay, so we're going to stop in 20 epochs. Okay, so it's pretty good. If you want to test the classifier, you just put in um, the file path. That's what this means. Again, if you want to get the file path, just go to where the image is in your drive. Train, test. Okay. Okay, so we want to test for Jennifer Aniston. In this case, we're testing 20. Let's test the 6. Okay, so I could just do a copy path, put it into that, right? And then check for that. Okay. And then we prepared the image. Now, in preparing this image, basically, let's put a 6 here. Now, if you watch, this is content drive my drive recognizer test Aniston. Content drive my drive recognizer test Aniston. Aniston. This is the folder where the images are, right? So you could actually just say image directory here or image path. They mean the same thing. Yeah, just copy out this code, and all you need to do is add the particular name of the image. In this case, the particular name of that image is 6.jpg. So it's telling us this image is an image of Jennifer Aniston. Now, I've explained this whole code before. This is how the image, this is how it is going to come out. I told you guys it's going to come out in numbers. So you have to turn the numbers to something that can be understood. Remember, we've worked on print statements in Python class, right? So you're saying if the max index, the max of the two or max of all the list is index 0, print this. In your case, you might have more than one. In this case now, there are only two items in the list. In your own case, you might have 5 items, 4 items, whatever it is. So basically what you're going to do is if max index is 0, or if max index, else if, could do this, else if max index is 1, you could say print this image is an image of whoever it is, right? Then if you have another image again, else if max index is an image is 2, for as much as you need to do up until you get to the end, right? You don't even have to put in, okay, you know what? We could just remove the else. You don't even have to use an else, but I would want to use, right? Okay, so you could do it this way, right? And then you can use as much images as you have. But how do I know the arrangement? How do I know that this particular number is Jennifer Aniston and this particular number is Chris Brown? What do? You could just get the use this where OS comes into play. OS dot lists. Now, if you have not imported OS, you're going to have an error. So you have to import OS list there. So I'll pick out the particular directory where they are. I could just pick out this directory here. Paste it there. Let's see. Okay, so you can see how it arranged it. It puts Aniston first and it put Chris next. So that means this is Aniston and this is Chris. In your own case, you might have more than one image here. You can see that's why I used os.list there. This gives you the arrangement of the names. So what you could do, yeah, so that's basically it. You know what? Let's just take this out, cut it out, and just put it here, right? And then of course we could print names. Still the same thing. Okay, why is it different here? Let's see. Interesting. Okay, but we're actually testing with the test image, so we don't need to use. We're using the test image, so let's see. Yeah. So because we're using the tests, we have to use the test arrangement. So that's why he arranged it this way. So for index 0 is Aniston, index 1 is Chris, right? So I hope this makes sense, guys. I hope you don't have any issues. Let me see. Does anybody have any issues? Okay, so I'm not seeing any questions. All right, so on that note, guys, I would call this a day. It's been amazing with you. Watch the videos over and over. By the time you're done, by the time you get to this video, it should all make sense to you. All right, guys, I'll see you next week. Work on your project, and great being here with you. Hello. So we've come to the end of the class. I'll see you guys in the next class.